Hello student, this is Suman Sharma from SBM Sinidih and this is the next video for class 10. In this video, we will study about Ohm's law. To understand Ohm's law, we take a very common and a very simple example. We take an example of a torch. We know that when we insert the battery in the torch or the cell in the torch, then the torch will glow. It's something like this. And when we use the torch after some time, then we see that the intensity of the glowing of the bulb gets dimmer. But why the intensity of the glow of the bulb gets dimmer? Because the voltage of the cell decreases, as it is also written here that the voltage of the cell decreases and the glow of the bulb gets dimmer. Here the word gets dimmer. What is the meaning of the bulb gets dimmer? Dimmer glow of bulb means that less current is flowing through it. And this means the current decreases with the decrease in voltage. The current decreases with the decrease in voltage. Now, after some time, the cell becomes dead or the battery discharged. The cell becomes dead, it means it has zero potential, it has zero voltage, and when the voltage is zero, that means no current flows through the torch or the bulb doesn't glow. But when we insert the new cell in the torch, then again the bulb of the torch starts glowing brightly. This bright glow means what? This bright glow means that more current is flowing through the battery. There's more current flowing through the bulb. This means that the current increases with the increase in voltage. Now, we know that the another name for the voltage is potential difference. That means when the potential difference changes, then the current also changes. Means the potential difference increases, then the current increases. When the potential difference decreases, then the amount of current is low. And this rule or this law is firstly discovered by the German physicist George Simon Ohm. So in honor of him, this rule is named as Ohm's law. So if we want to write the statement for the Ohm's law, we know that from the previous slide that Ohm's law is the relation between the potential difference applied to the ends of the conductor and the current flowing through the conductor. And this law was first expressed by George Simon Ohm in 1826. If we want to write the statement of Ohm's law, we have to keep some physical state of the conductor remains unchanged. And in that physical state, the temperature or the mechanical strain. So, firstly we have to take the temperature of the conductor remains constant. After taking the temperature constant, when the current flowing through the conductor is directly proportional to the potential difference across the two ends of the conductor. So, this statement is written in the mathematical form like this. We know that here the two quantity current and potential difference. These two quantities are directly proportional to each other. It means if one quantity increases, then the other quantity also increases. And if one quantity decreases, then the other quantity also decreases. And this expression can also be written as this, because in directly proportional, its reverse is also valid. Now, V proportional to I, and V is equal to IR. When we remove this proportional sign, then we have a equal sign and a constant quantity R. Means if I written here V proportional to I, then V is equal to RI. Here R is the constant of proportionality, and this constant of proportionality is called resistance. Here V is the potential difference and I is the current. This is the statement for the Ohm's law. Now, in the next slide, we have from Ohm's law, V is equal to IR, and if we want to solve the expression for the resistance R, then it becomes resistance is equal to potential difference by current. This means the electric resistance is simply the ratio of potential difference across the two ends of the conductor and the amount of current flowing through the conductor. So, this is the electrical resistance. Now, from equation 4, the expression for current can also be calculated as I is equal to V by R. From this relation, we know that current is directly proportional to the potential difference, as you can see here, and current is inversely proportional to the resistance. Here, the current is inversely proportional to the resistance means when the two quantity is inversely proportional to each other, it means that when we increase one quantity, then the other quantity decreases, and when we decrease one quantity, then the other quantity increases. It means when current is inversely proportional to resistance, if we increase resistance, then the amount of current decreases, and if we decrease resistance, then the amount of current increases. So, this is the relation between current and resistance. Now, if a graph is drawn between the potential difference and the current, the graph is found to be a straight line passing through the origin, because both the quantity, potential difference, and the current is directly proportional to each other, as you can see in the next slide. From the graph, we see that the two quantity, potential difference and current are directly proportional to one another. From this graph, here the current is taken in the x-axis and the potential difference is taken in the y-axis. The current I increases with the potential difference, but the ratio V by I remains constant, and that constant quantity we have defined the resistance of the conductor. Means when the amount of current increases as the potential difference increases, but at any point if we find the ratio of potential difference and current, then the quantity which comes always a constant quantity, and that constant quantity is known as resistance. Now we know that how to find the slope of the curve. As you can see here, the slope of the line is solved like this, that slope is equal to potential difference by current, and this potential difference by current is defined earlier as the resistance. So the slope of the line is actually the resistance of the conductor. Now in the next slide, here the word come resistance of a conductor. To understand resistance means simply the opposition to flow. Suppose that we throw a ball in upward direction in air, then the ball faces the opposition by air. This is the first example. If we take the another example, if we swim, then while swimming we experience this opposition by water. And the third example is, if we want to run in a crowd, then we feel difficulty or we face opposition moving through the crowd. So the generalization is that the continuous flow of any substance faces opposition due to the various reasons. Similarly, the flow of electrons also faces some opposition, and this opposition of electric current is nothing but the resistance. So, this opposition of electric current is nothing but the resistance, or we can say that in scientific terms, this opposition is known as resistance. So, if we have to define the resistance, then resistance is the property of a substance. Resistance is a property of a substance by which it opposes the flow of electric current. This is the simple definition of resistance. And for the calculation of resistance, we use the formula resistance is equal to potential difference by current. We know that the SI unit for the potential difference is equal to volt, and SI unit for the current is ampere. So, the SI unit for the resistance becomes volt per ampere, as it is firstly discovered by Ohm. That's why in honor of him, the SI unit for the resistance is also Ohm. So, this is the relation between Ohm, volt and ampere. So, SI unit of resistance is Ohm and SI unit of resistance is also volt per ampere. Now, we have to define 1 ohm. So, simply 1 ohm is the resistance of a conductor when a potential difference of 1 volt is applied across the two ends of the conductor when the current of 1 ampere flows through it. Simple. When the potential difference is 1 volt and the current flowing through it is 1 ampere, then its resistance is 1 ohm. So, this is the definition for 1 ohm. In the next slide, the topic is on the basis of electrical resistance, all the substances can be classified into 3 groups. It means all the substances have different resistance. So, on the basis of their resistance, all the substances are classified into 3 groups. First is the good conductor. Those substances which have very low electrical resistance or simply which have very low resistance is called good conductor. You know, silver is the best conductor, but it is very costly. That's why we are not using it in our home for the wiring purpose. Besides silver, copper and aluminium is also good conductor because it has low resistance. The second is resistor. Those substances which have comparatively high electrical resistance are called resistor. Those substances which have comparatively high electrical resistance means the substance which have high resistance in compared to the conductor is called resistance. For example, nichrome, manganese and constantine. These are the 3 alloys which have comparatively high resistance in compared to the good conductor are called resistor. We will explain it after a while in our next video. Now the third is insulator. Those substances which have infinitely high resistance are called insulator. You already know this. For example, rubber, plastic, these are the example for insulator. So, I hope students that you understood the topic given in this video, and this is enough for today. Thank you so much.